to Projects. In this video, we are going to explain about the project, which is machine learning approach to anomaly detection attacks classification in IoT devices. Introduction of the project. The project addresses the expanding landscape of Internet of Things, which extends web connectivity beyond traditional smart devices to encompass a wide array of everyday physical objects. These IoT devices, ranging from small household appliances to larger industrial equipment, transmit valuable sensor data to users, corporations, and various stakeholders. The IoT ecosystem is categorized into three main sectors, which is consumer, enterprise, and industrial. Consumers select devices based on specifications, conditions, and prices, and Margaret Lee's projections suggest a proliferation of 64 billion IoT devices online by 2025. Recognizing the significance of anomaly detection in IoT, defining anomalies as patterns in the data that deviate from expected behavior. Anomaly detection plays a crucial role in identifying outliers, exceptions in irregularities, or surprises in IoT functions. Leveraging anomaly detection that can help detecting abnormal behavior, revealing significant events or potential opportunities such as technical issues or shifts in consumer behavior. Acknowledging the vulnerability of IoT devices due to their internet connectivity, the project emphasizes the necessity of addressing security issues. It highlights instances of attacks on IoT devices such as the Western's Digital MyBook Live incident, where hackers exploited system vulnerabilities to reset devices and wipe out data. The project underscores the increasing vulnerability of IoT devices and the need for robust security measures. The primary objective is to emphasize the limited existing research on machine learning approach to anomaly detection in IoT devices. The project proposes a feature selection method classifying anomaly detection attacks using machine learning design, a detection technique employing machine learning algorithms, and evaluate the results against existing literature. Objective of the project. The primary objective is to address the dark side of IoT devices, acknowledging their susceptibility to misuse by hackers and intruders, posing potential threats to users. The project aims to mitigate security issues in IoT devices by proposing the application of machine learning algorithms, specifically focusing on anomaly detection techniques. The project employs support vector machine and random forest as a powerful supervised learning algorithms to detect and address anomaly attacks in IoT devices. The project involves experimentation using NSL-KDD dataset, a standardized anomaly dataset. This dataset is crucial for assessing the effectiveness of the proposed machine learning algorithm in detecting anomalies in IoT environments. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this step, essential Python libraries have been imported. We have imported Pandas for data manipulation, NumPy for numerical operation, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, Flask for web development. The next step is exploring the dataset. In this module, the focus is on understanding the structure and characteristics of the NSL-KDD dataset. The dataset is loaded and inspected to comprehend its features, data types, and potential patterns. Coming to data processing, here we have sub-steps. Converting data into Pandas data frame. In this step, the raw dataset is converted into a Pandas data frame for ease of manipulation. Relevant Pandas functions are employed to read the data into a structured format. Dropping unwanted columns. In this module, unnecessary or irrelevant columns are dropped from the data frame, streamlining the dataset for further analysis. Label encoding using label encoder. In this step, categorical data is converted into numerical format that is suitable for machine learning models using Scikit-learn's label encoder. The next step is visualization using Seaborn and Matplotlib. In this module, visual insights into data distribution and relationships are gained. Seaborn and Matplotlib are utilized for plotting histograms, scatter plots, and other relevant visualizations. The next step is feature selection using select percentile. In this step, the focus is on identifying and retaining the most informative features for subsequent model training. We have used select percentile method for this purpose. The next step is appending features to X and target to Y. In this module, from the selected features are assigned to X and the target variable is assigned to Y to prepare for model training. The next step is splitting the data into train and test. In this module, the dataset is divided into training and testing subsets. Using scikit-learn's train test split, this division is crucial for evaluating the model's performance. The next step is building the model. In this critical step, the foundation framework for machine learning model is established. Here, we initialize the model with relevant parameters. The objective is to create the structure that will learn from the provided dataset and make predictions based on patterns and relationships within the data. This step lays the groundwork for subsequent training and evaluation phases. The next step is training the model. In this step, the machine learning model is trained using the training data. The model learns to recognize patterns and relationships in the provided dataset, adjusting its parameters for optimal performance. The next step is Flask framework with SQLite for sign-up and sign-in. In this module, a web framework using Flask and SQLite as database is established for user interaction. This step includes functionality for user sign-up and sign-in. The next step is user gives input as feature values. In this step, users are prompted to provide input for the features, as user interface is designed to collect feature values. The next step is the given input is pre-processed for prediction. In this module, user-provided input is prepared for prediction by applying the same pre-processing steps as the training data. This ensures consistency in the data format. Trained model is used for prediction. In this step, the machine learning model is previously trained and it is employed to make predictions based on the pre-processed user input. The last step is final outcome is displayed through front-end. In this module, the prediction outcome is showcased to the user through the front-end interface. The final prediction is displayed for user interpretation and analysis. Algorithms which are used in this project are random forest. It is a popular machine learning algorithm that belongs to the supervised learning technique. It can be used for both classification and regression problems in ML. It is based on concept of ensemble learning, which is the process of combining multiple classifiers to solve a complex problem and to improve the performance of the model. Random forest is a classifier that contains a number of decision trees on various subsets of the given dataset and takes the average to improve the predictive accuracy of the dataset. Instead of relying on one decision tree, random forest takes predictions from each tree and based on majority votes of predictions and it predicts the final output. We have built random forest using K-fold. K-fold cross-validation is a technique for evaluating predictive models. The dataset is divided into K subsets or folds. The model is trained and evaluated K times using a different fold as a validation set each time. Performance metrics from each fold are averaged to estimate the model's generalization performance. Random forest using K-fold 10 employs 10 folds for cross-validation. The model is trained and evaluated 10 times with different subsets of the data using testing in each iteration. Random forest using K-fold 20. Random forest using K-fold 20 employs 20 folds for cross-validation. The model is trained and evaluated 20 times with different subsets of the data used for testing in each iteration. It is chosen for its capability to handle complex data sets, which is common in IoT applications. Its ensemble nature, combining multiple decision trees, is beneficial for capturing diverse patterns and mitigating the risk of overfitting in the presence of various IoT data characteristics. The next algorithm used is support vector machine. Support vector machine or SVM is one of the most popular supervised learning algorithm which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called as hyperplane. SVM chooses the extreme point, which are vectors, that help in creating the hyperplane. These extreme cases are called as support vectors. Hence, algorithm is termed as support vector machine. Here, we build support vector using K-fold, which are 10. SVM using K-fold 10 applies K-fold cross-validation with 10 folds. The dataset is divided into 10 subsets, and the SVM model is trained and evaluated 10 times, with different folds using per test in each iteration. SVM using K-fold 20. SVM using K-fold 20 applies K-fold cross-validation with 20 folds. The dataset is divided into 20 subsets and the SVM model is trained and evaluated 20 times with different folds used for testing in each iteration. SVM is selected for its effectiveness in handling high dimensional space, making it suitable for IoT environments where multiple features contribute to anomaly detection. SVM's ability to find optimal hyperplane is valuable when dealing with intricate decision boundaries in the complex IoT dataset. As an extension, we employed an ensemble method that amalgamates predictions from multiple individual models, enhancing the overall robustness and accuracy of the final prediction. Additionally, we expanded the project by developing a front-end using Flash framework to facilitate user testing, complemented by user authentication for added security. We have evaluated this project using different evaluation metrics which are accuracy, precision, recall, and F1 score. Here we have comparison graphs for those metrics. This is accuracy comparison graph. Here on x-axis we have accuracy score for each algorithm and on y-axis we have algorithm names. Accuracy simply measures how often the classifier correctly predicts. We can define accuracy as a ratio of number of correct predictions and the total number of predictions. This is precision comparison graph. It explains how many of the correctly predicted cases actually turn out to be positive. Precision is useful in the cases where false positives is higher concern than false negatives. This is recall comparison graph. It explains how many of the actual positive cases we were able to predict correctly with our model. Recall is a useful metric in cases where false negative is of higher concern than false positive. This is F1 score comparison graph. It offers a balanced measure of model's performance by considering both false positives and false negatives, serving as a harmonic mean of precision and recall. The model which performs well among all these metrics will be used for prediction. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is NSLKDD folder which contains dataset. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, and this file contains the algorithm information and that will be loaded into the project code during runtime. This is notebook file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is sign up file. This is the database file used to store the user information. Now to execute the project, first we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file and this will execute Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, Flash framework will host the application locally at the default address, which will be the local host and the port unless configured differently. This is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. We can see the web page of the project is displayed in the browser, and this web page is built by using the Flash framework. Here we can see a sign up link. First we need to click on that and enter all the sign up details if you are signing up new. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now we need to click on sign in. We have signed in successfully. Here we can see the parameters which are need to be entered. Based on the given parameters, the system will predict. Now we will understand all these parameters. Here we have service. This parameter represents the network service on which the connection is initiated or attempted. Understanding the service helps in analyzing the nature of network activities. This is flag. It indicates the status of connection, specifying whether it is normal connection, an error, or another state. It provides insights into the communication state during network activities. This is source bytes. It denotes the number of bytes sent from the source, which is initiator of the connection, to the destination. It measures the volume of data transmitted in the outbound direction. Here we have destination bytes. It represents the number of bytes received by the destination. It measures the volume of the data received in the inbound direction. This is count. It signifies the number of connections to the same host as the current connection in the past 2 seconds. It provides information about the frequency of connections to a specific host. Here we have error rate, which is source error rate. It is a percentage of connections that have SYN errors. SYN error occur during the initiation of a connection, and it can be indicative of potential issues or attacks. Here we have SRV's error rate, which is service source error rate. It specifically calculates the error rate of the server side. It measures the percentage of connections with server side SYN errors. Here we have same SRV rate. It represents the percentage of connections to the same service, which is network application, among the total connections. It helps in identifying patterns in the service usage. Here we have different SRV rates. It is the percentage of connection to the different services among the total connections. It provides insights into the diversity of the services accessed by the network. Here we have destination host SRV count. This parameter signifies the count, number of connections to the same service on the destination host. It helps understanding the level of the activity on the destination host for a specific service. Here we have destination host same SRV rate. It is the percentage of connections to the same service on the destination host among the total connections to that host. It provides a relative measure of service consistency on the destination host. Here we have destination host different SRV rate. It calculates the percentage of connections to the different services on the destination host among the total connections to that host. It offers insights into the service diversity on the destination host. Here we have destination host error rate. It represents the percentage of connections with SYN errors on the destination host. It measures the error rate specifically on the destination side. Here we have destination host SRV error rate. It calculates the percentage of connection with server-side SYN errors on the destination host. It provides a focus measure of server-side errors on the destination host. Now we understood all the parameters, we will enter them step by step. So the service value is 20, flag is 9, SRC bytes are 491, destination bytes are 0, count is 2, error rate is 0, SRV error rate is 0, same SRV rate is 1, different SRV is 0, destination host SRV is 25, destination host same SRV is 0.17, destination host different SRV is 0.03, destination host error rate is 0 and destination host SRV error rate is 0. Now click on predict. Based on the given parameters, it has predicted as there is no attack detected and it is normal. Now we will enter parameters again. Click on home. So the service value is 49, flag is 5, source bytes are 0, destination bytes are 0, count is 123, error rate is 1, SRV's error rate is 1, same SRV is 0.05, different SRV rate is 0.07, destination host SRV is 26, destination host same SRV is 0.1, destination host different SRV is 0.05, destination host error rate is 1 and destination host SRV error rate is also 1. Now click on predict. So here it has predicted as there is an attack detected and the attack type is DDoS. Now we will enter the parameters again but with different values. Click on home. I entered all the parameters. Now click on predict. Based on the given parameters, it has detected as there is an attack detected and the attack type is R12. Now we will enter parameters again. Click on Home. I have entered all the parameters. Now click on Predict. So here we got the prediction as there is an attack detected and the attack type is proc. In this way, if we entered all the required parameters, then the system will predict which type of attack it is. Now click on Sign Out. Conclusion of the project. The successful application of machine learning algorithms, specifically support vector machine and random forest, highlights their proficiency in detecting and mitigating anomaly attacks within IoT devices. Results indicate a commendable performance of the proposed method, surpassing existing literature. The accuracy achieved demonstrates the reliability of the approach in addressing anomaly issues in IoT environments. Emphasizing the reliability of the method, the project ensures a sustained low false positive rate across various scenarios. This consistency is pivotal for precise classification of anomaly attacks in the diverse landscape of IoT devices. The project rigorously evaluates the proposed machine learning algorithms using NSL-KDD dataset. This standardized dataset serves as a robust benchmark for assessing the practical effectiveness of anomaly detection in IoT. This project significantly contributes to bolstering IoT security by introducing a method that not only demonstrates notable efficiency but also addresses the critical challenge of anomaly attacks, thereby enhancing the overall resilience of the IoT devices against potential threats.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.